Okay, now let's move to DP3 and DP4, and then DP4 is our final solution. Now for DP3, we see that we have got a length of 4, which is even. So again, using the same even length approach, that we have to expand from center with 2 characters as center. So here, if you see that if we choose centers are these 2 characters, right? But here we see that the center of 2 characters, I mean, this is even not same, right? A is not equal to B. So even the center is matching here. So we can't find any. We cannot approach this problem using like the algorithm that we discussed here. It will always be. We will always solve this problem when the center of 2 characters are also matching for the even length. So here we don't find any 2 center characters which are matching. So we don't have any solution, and we just use the solution that we have used for DP2. For example, we have already calculated what is the final longest substring possible, palindromic substring possible for DP2. So we'll just choose default to the one which was there. So for this case, it would be still DP of 2, or we can say I minus 1. We are removing this, and this is the longest palindrome possible for these 4 characters, which is TP I minus 1. So it would be BAB only. I'll mark this as BAB. So till this string, we have found the maximum, the longest palindromic substring of BAB. Now let's move on to the last one, DP4, which will give our final solution. Now we are with DP4, and this is our original input string, and we see that it has got a length of 5, which is an odd length. So here for odd length, we again got the same formula that we expand from center with 1 char as center. So this is our center. So if we start from here, this is our center, and then we take L is equal to I, R is equal to I. Here I would be 0, 1, 2, right? So let me write it down as well. So here L is equal to center is 0, 1, 2, and similarly R is 2, and then we take of course, I mean, if we are just taking 1 character, it will be always correct. Here in the even case, we have to see that the 2 characters in the center that we are considering, they are matching as well or not. But for odd, I mean, because it's only 1 character, we can always start from here. And now we see for L minus 1 is this character, A. So, and R is equal to I plus 1, that is 3, which is, and these 2 characters are matching. So we are just using the same formula here. We iterate for R, L is equal to L and R, and we compare that character, so it's matching. So far, so these are matching, so it means that we have got a length of 3, which is ABA, which is our one of the solution. And then we further move from left to right. So we have covered this part, L and R are here, and we have extracted this string as our palindrome now, ABA. And then we again move to this, and we see that this B character is not matching with D, right? So we stop here because we are not, it's not matched, and after this we cannot move further because of the string it will be overflow condition. And this is so far we have found a length of 3, which is ABA. So using this approach for the final DPN4, we found that the longest palindromic substring that we have found is only ABA of length 3. And if we compare the string that we have already found, BAB, we found that the characters are, the length is still same. So we can either return BAB or ABA. So it can be a solution if we compare that with, we're just comparing if we have already found something which is already greater than this, but it's not greater than this, we can return either ABA or BAB. And this is our final solution. So in the next video, we'll solve this problem in Java as we have just discussed here. So again, to revise that, if it's an even length, we expand from center with 2 characters, LL, as center, and we also see that before starting, these 2 characters are same or not. And for odd length, is more straightforward. That if we just choose the center, which will always be matching, so we will be having at least one palindrome of length 1, and then we move on left and right and expand from center and see whether it's matching or not. So see you all in the next video.